Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please do let me know. Hello everybody, I hope that I'm live right now. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please do let me know guys. Good evening everybody, good evening, good evening, good evening. Is there any issues with my audio or the video guys? Please do let me know. No issues. Okay, that's great. Good evening, everybody. How are you? How is everybody today? No issues. No, fine. Okay, that's great. Okay, so how is everybody? Please let me know. How was your day? I'm also fine. Thank you so much, Sushant, for asking. Good evening, everybody. Good evening. Okay, so that's great. That's great. So, can somebody remind me what have we studied in our previous class? In the last class, what are the things that we studied? Can somebody remind me about the same? Good evening, everybody. Good evening. Can somebody remind me what have we studied in our previous class? We got a quick introduction to vectors, two type of arrays, array indexing, okay, loops. What was the question? Okay, yeah, that's great. We were searching in about an element in an array. Okay, that's great. Dynamic arrays, searching. Okay, that's good. Yeah, Vaibhav, there will be no issues in that if you're attending the class with a different account and giving your attendance with a different account. There's no issues in that. Advantages of dynamic sized rig, that's great. Two type of arrays, fixed size and dynamic sized. Okay, so you guys are able to remember everything that we learned in our previous class. Okay, that's amazing. In our today's class, we are going to look at insert operation into a fixed size array, as well as how to do the exact same insert operation in a vector as well. So we'll be looking at these two things. Okay, first we'll be looking at how to insert an element at a particular position inside of our fixed size arrays in C++. And once we have learned about it, once we have learned about how it works and everything, then we'll be looking at how to do the exact same thing, that is inserting an element into a vector. Okay, so these are the two things that we'll be doing today. Are you guys able to understand this? Please do let me know. Are you guys able to understand this? Please do let me know, guys. Okay, that's good. That's great. Okay. So we'll be starting in 2 minutes, guys. Up till that point of time, if you guys have any questions, any queries, please do let me know. We'll be starting in a minute, guys. If you have any questions or any queries, please do let me know, guys. If you have any questions, any queries, guys, please do let me know. Thank you so much, Deepak. Okay, no issues in that. So, let's get started, guys, with our today's problem statement. So the problem statement is extremely simple. Okay, we are going to start off with first of all inserting an element into a fixed size arrays. Okay, once we have completed with that problem statement, then we'll be shifting towards to how to do the exact same insert into a vector as well. So this will be our first program that we'll be doing with vectors. Okay, so I hope that there will be no issues of any kind while we are doing the same. And yeah. Okay, 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 so let's get started, guys, with the same. Let me just open up the live chat and then we'll get started with the same. Okay. Okay, so let's first understand how to like make the entire stuff. Let's understand the questions and everything. Okay, and then we will start off with the rest of the stuff. Let me just delete everything up. Please focus upon the class itself right now, guys, and you will be able, it's very easy, you will be able to understand everything. So for example, let's say that you are having an array. Let's take up 5, 10, 20 right over here. Now, as this is a fixed size array, guys, okay, so the fixed size array of size 5. Okay, so this is a fixed size array that has a capacity of 5. Okay, the maximum number of elements that it can hold is 5 itself. Okay, so right over here, as you're able to see, we are having a fixed size array that has a capacity of 5 and it has 3 elements inside of it. So the size of the array is equals to 3 right over here. The capacity is 5. Okay, that is, it can contain 5 elements, and the number of elements in this particular array right now is 3. Are you guys able to understand these two things? These are two separate things. It is a fixed size array that has a capacity of 5, that is, it can contain at most 5 elements, and right now inside of it, it has 5, 10 and 20. That is 3 number of elements are there inside of it. So n would be equal to 3 right over here. Are you guys able to understand these two things? Please do let me know. Okay, great. So now, for example, if I want to insert an element at a position, let's say 1, okay, if I want to insert 3 as an element, so x is equals to 3, this is the element that I want to insert at position 1. Okay, so by position I means index. Okay, so POS, that is index, is equals to 1 right over here. Okay, so what will be the new array that I will be able to get? Can somebody let me know what will be the new array that I will be able to get? If I want to insert an element that is 3, that is x equals to 3, this is what I want to insert at index, that is position is equals to 1, what will be the new element that I will be able to get? Okay, now new array that I will be able to get. Can somebody let me know? That's absolutely okay. No, I'm talking about insert. See, there's a big difference between insert and replace. Okay, I'm talking about inserting an element, not replacing an element. Okay, I want to insert it at the position, or that is at the index 1. So as you're able to see, this is 0, 1, 2, 3 and 4. I want to insert the new element right over here. Okay, so the new array that I will be able to get would be 5, 3, 10, 20 and hyphen. Okay, so this would be the new array that I will be able to get. Can you guys let me know what will be the value of n for this new array? Can you guys let me know what will be the value of n for this new array? What will the value of n for this new array? Can somebody let me know? What will be the value of n for this new array? Can somebody let me know, guys? The value of the n would be 4. Okay, the value of, because we have added a new element, we have inserted a new element right over here. And what will be the value of cap, guys? What will the value of cap? What will be the value of cap, guys? What will be the value of cap, guys? That's absolutely clever, Anonymous. The value of cap, that is capacity, will still remain the same, that is 5. Because we cannot, it's a fixed size array. We cannot contain any more number of elements than the capacity. So the capacity will always remain as 5 itself. Okay, so this is what we want to do. Now, in the case when the array is filled, are you guys able to understand this example? Are you guys able to understand this example? Please do let me know, so I'm able to get to the next example, guys. Are you guys able to understand this example? Please do let me know, guys. Are you guys able to understand this example? Please do let me know. Great, amazing, guys. You guys are so smart. Okay, amazing. So what if the array was already filled up? Okay, if we are having an array, let's say 5. Just a second. 5, 3, 10, 27. If this is the array that we are having, okay, right over here. And if I, so as you're able to see here, n is equals to 5. That is the total number of elements in this array is 5, as you're able to see. The capacity of this fixed size array is also 5. So the capacity is also 5 right over here. Okay, so what is the like if I want to insert 6, okay, if I want to insert 6 into this array, okay, at position, so x equals to 6 that I want to insert at position, that is index is equals to, let's say, 4. Okay, if I want to do that, there is no space left, as you are able to see. As you're able to see, there is no space left in the array. Okay, all the elements, like the array is already filled up. Okay, there's no space. N is equals to 5. That is total number of elements in the array is 5, and that is equal to the capacity. So I cannot insert any more elements anywhere inside the array. Okay, this is a fixed size array. I cannot expand. I cannot increase the size as well. Okay, this is a fixed size array. I cannot increase the size as well. So from this example, you will be able to understand that if the array is filled up, if there is more number of elements in the array, okay, if the array is already filled up, I cannot insert any more elements right over here. So you cannot insert anything else inside of it. Okay, so there will be no insert option. So the answer at the end will come up the exact same as 5, 3, 10, 20 and 7. I cannot insert the element into the array. This is the problem statement that we are having. Okay, this is the problem statement that we are having. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. Are you guys able to understand this? Please do let me know, guys. Okay, that's great. Amazing, guys. Amazing. So let's start about thinking about, first of all, let's go and create the basic code itself. So what we are going to do is we are going to go back to our IDE. Let's search for an IDE, C++ online compiler. Let's take a programmers. I'm so sorry for my cough. Okay, so hashtag include iostream, and let's just make the basics right over here. Using name is PACESTD. Let's remove this. Let's check everything is working or not. So everything is working properly, so we don't need this right over here. Let's remove this and let's start writing our, first of all, let's create our fixed size array. So int arr, and I want the array to be of size 5. Okay, int capacity. Okay, so the cap or the capacity of the array is also 5. Okay, int n is equals to 3. That is the total number of elements present in the array right now is 3. Okay, now let's fill up the array. Okay, so arr at 0th index, that is the 0th element in the array, should be equal to 5. Then the next would be arr 10 arr1, that is at the first index we are going to have 10, right? It was 20 or 10. Okay, what was the example that I took? Check what was the example that I took. You guys must have posted it in the live chat. 20. Okay, it was 20 right over there. So 20, and then arr, no, it was 10. Okay, then arr at the second index would be equal to 20. So this is how we are able to create our array right over here. So once we have created our array, let's just print our array on our screen so that we are able to see that everything is working properly. So see out less than before insertion before insert less than end L. So now end L. So if you are putting up this end L at the end, okay, if you're putting up end L at the end, that means that you want to end the line right over there and you want to go to the next particular line. Okay, so how end L is used is for example, it will print out before insert, and then you are having end L right over there, that is end line. So the cursor that is there, that is printing it out in the console, it will go to the next line. Okay, it will start printing from the next line, and that is what we want. So before insert, then the number of all the elements in the array. So to print out all the elements in the array, just like yesterday, we are going to use a for loop. For int I is equals to 0, I is less than n, I plus plus, we are going to have C out less than ARRI, that is the element, and then of course between two elements we want to have a little bit of space as well. The next thing that we'll be printing is a space. So for example, we'll first print 5 and then a space, then print 10, then a space, and then print 20, then a space. Okay, so this is how you are able to maintain like you are able to print out the entire array using these spaces. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. And as you are able to see, there is no end L right over here. That means that every like element of the array will be printed in the same line. Every element of the array, because there's no end L, so every element of the array will be printed in the same line. Are you guys able to understand this? Please do let me know. Now at the end you want to go to the next line. Okay, once you have printed all the elements in the array, you want to go to the next line, so you will again do cout less than end L right over here. Okay, so that after printing out all the elements in the array, the cursor is going to the next line right over here. So let us run this. Let us see if everything is working properly or not. So as you're able to see, before insert, then you are having in the next line all the elements that you wanted to print, and then because we are having a cout and L at the very end, so the cursor is going to the next line, as you're able to see. Are you guys able to see this? Please let me know. Are you guys able to see this? Please let me know, guys. Great. So now what we want to do is we want to have an int x is equals to 7. Okay, that let's say 6. Okay, int x is equals to 6 right over here. That is what we want to insert, and we want it to be inserted at position. So int pos is equals to 1. That is at the index 1 we want to insert x. Okay, at the index 1 we want to insert 6. Okay, so that is the question that we are having. Okay, so for that we are going to create our insert operation. Now if you remember it correctly from our drawing before, okay, what is the only thing that gets changed when we are making a new array? Okay, if there is an insert operation, what is the only thing in the array that gets changed? Can somebody let me know? What is the only thing that gets changed in the array when we are doing an insert? Okay, if we are doing an insert, what is the only thing about that array that changes? Can somebody let me know? Just think about it, guys. The size increases. That's absolutely clever. So only n is getting changed. So the operation, that the function that we are going to create, the insert function, for that the only thing that is getting changed is n. Okay, that is the number of elements in the array. So what we are going to do is we are going to return n, that is the size, the new size of the array itself. So insert is the function that we are going to create, insert, insert right over here. Let's create this particular function. Let's go up and create the entire function itself. So we are going to go up right over here. Now, as I said, that the size is the only thing that is getting changed. That is the number of elements, that is n. Now n is an integer. So the return type of our function that we are going to create, that is the insert function, we are going to create as an integer itself. So int insert, and then this is our function. This let's return 0 so that we are not able to forget anything. Okay, just like we are not creating the function right now, just making the basics itself. Okay, so let's go back. Let's try to understand how the code should be made as. Now, in what condition are we not going to insert an element into that array? Can somebody let me know? In what condition, in what particular situation are we not going to insert an element into that array? Can somebody let me know? If the capacity is already filled up. Okay, so in the condition, okay, in the condition in which the n is equals to capacity. Okay, if in the condition where the size is already filled up, that is n is equals to capacity itself, in that particular condition we don't want that function to be executed. We don't want insert function to get executed. Okay, if the array is already filled up, we don't want an insert to happen. Okay, so we are going to if, okay, if n is equals to cap, okay, if in the condition that n is equals to cap, then in that particular condition we are going to do return. So if we are not going to do an insert, what will be the size of the array, guys? What will be the size of the array if we are not going to do an insert, guys? Whenever you write return, your entire app function stops right over there. Okay, your entire function stops right over there and it gives back the value that you're returning. Okay, so if n is equals to cap, that is the capacity is already filled up, what should the function return back to us? What should be the function return back to us, guys? What is the new size of the array? The new size of the array is n, guys. Okay, the new size of the array is n, so it will return n back to us. Okay, it will return n back to us. So this is the first condition that we have to make, that if in the condition that the array is already filled up, I don't want this particular insert function to run. Okay, I just return n back. Okay, stop this function, return n back. Okay, so we are going to write this particular code. First of all, we are going to have if, okay, if n is equals to capacity, okay, if n is equals to capacity, return n back. Okay, this is where the entire function will stop. It will just return n and that's it. It won't it won't do anything else in front of it. Okay, it will not do anything else in front of it. Okay, like I said, okay, if in the condition that n is equals to capacity, that is when the capacity is already filled up, number of elements in the array is exactly equal to the capacity of the array, you're not going to do the insert function. We are going to write our insert function right over here. Okay, we are going to write our insert function right over here. We don't want that insert function to run. So in that case, I will just be returning n right over here. The function won't work anymore. Okay, it will just give n back. That is the size of the new array and that's it. Okay, that's it. Okay, so it is basically checking us for the second example that I gave. The second example that I gave, it is preventing that from happening. It will not insert anything into the array itself. Okay, so first of all, we are going to use n and capacity right over here. So we need to define it right over here. So int n comma int cap, and we need to provide it inside our call itself. This is something that we have seen yesterday. So we are going to call for n and cap right over here. Okay, we are going to provide the calling of the function with n and cap as its parameters right over here. Now, once we have handled the edge case in which we don't want anything to be inserted, what if it's a normal array itself, okay, where n is less than your capacity, okay, number of elements in the array, like that is you can insert more number of elements in the array. So what to do in that particular scenario? Let's try to understand this. Okay, so let's take up some cards. Okay, let's take up some cards. So this is 5, this is 10, this is 20, and then there's like nothing else right over here, and then we are having another card 6. Okay, we are having another card 6 right over here. Okay, you are having another card that is 6 right over here. So if you want to insert 6 at this particular position, if you want to insert 6 at this particular position, you can pick up only one card at a time. Okay, you can pick up only one card at a time. So what will be the process that you will be doing? Okay, what will be the process that you will be following if you want to insert 6 at the index 1 and you can only pick up one card at a time? Okay, what is the process that you will be doing, guys? What will be the process that you will be doing? Can you think about it? Please do let me know. Can you guys let me know, what if you have to insert 6 in this particular array, what is the process that you'll be doing if you can only pick up one card at a time? Okay, you can only put up one card at a time. Okay, exactly, you will be shifting the cards to make space right over there. So what you'll be doing is, first you'll be shifting 20 to the next particular place. Okay, that's the first step. So you'll be having 20 right over here. Okay, and then this would be empty. Okay, this particular position would be empty right over here. Okay, then you will be shifting up 10 one place back. Okay, you will be shifting up 10 one place back. So now it will look something like this. Okay, you will be having 10 right over here. You'll be having 10 right over here, and then this particular position would be empty. Okay, this particular position would be empty. Once I've shifted all the elements, then you will be inserting the 6 at the free position. Okay, now this is the free position. Now you will be inserting 6 right over here. Okay, so you'll be inserting 6. So your final array would look something like this. Okay, are you guys able to understand this? Please do let me know. Are you guys able to understand this? Please do let me know how I shifted all the elements one place at a time, and then once that position that I needed was free, I inserted my element right over there. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. Just think about it, as you are able to pick up only one card at a time. How would you go further with it? Okay, just think about it. In that particular case, you will be easily able to understand this. Okay, just like your kindergarten, now you shifted one particular shape at a time to make space and then put up a space, another shape right over there. Okay, it's the exact same thing as that. Okay, very easy to understand. But now what you did right over here, you have to do the exact same thing in code. What you did right over here, you have to do the exact same thing in code. So what is the first thing that you did? What was the first thing that you did? The first thing that we did was the last element. We shifted it one place in front of it. Okay, so the last element was 20. If you guys remember, the last element was 20 right over here. Last element was 20. So 20 was present at the n-1 position. Okay, why n-1? N is the total number of elements in the array. So let us go back. Let us go back to the original problem statement. Okay, so as you're able to see from right over here, this was the original problem statement. Now n is equals to 3. N is equals to 3. That is the total number of elements that are present in the array. Okay, and the indexing, let's put up the indexing right over here. So this is 0, this is 1, this is 2, this is 3, this is 4. So if 20, that is the last element, at which position is it present, guys, in terms of n? The last element is present at which particular position, guys? Can somebody let me know? The last element is present at which particular position, guys? Can somebody let me know? n-1. That's absolutely clever. So 20 is present at n-1. So we need to start from I is equals to n-1. We need to start from n-1. We need to go up till the position. We want to shift to 10 as well. Okay, we want to make the position empty at the first position, at the first index. We want to make it empty. Okay, so you want to shift the 10 as well. So if you want to shift the 10 as well, you want to go up till the position at which you want to insert, that is POS. POS is the position that you want to insert it at. Okay, so you want to start at n-1, that is shifting the elements. You want to go up till the position POS. Okay, you want to go up till the position POS. So you want to have the next element as I should be greater than or equal to POS, guys. I should be greater than or equal to POS. Just apply. See, this is not programming, this is just common sense. Okay, those guys who are not able to understand, fucking apply your mind. Okay, this is just common sense, not programming. If the position, okay, the indexing is at 2, okay, 20 is present, the last element is present at 2 right over here. The total number of elements in the array, that's n is equals to 3. So how will you represent 2? That is n-1. That is n-1. That is 3 minus 1. That is 2. So the last element, so number of elements is 3, but the position at which the last element is present is 2. That is why you are going to start from n-1. That is the first element that you want to move further. Which is the last element that you want to move further? That is the element present at the position that you want to insert the new element. Okay, that is POS. Okay, that is the index 1. That is the index at which, that is the last index that you want to shift. Okay, so I should be greater than or equal to POS. Now you want to go from here towards here. So I first of all is n-1, then you want to reduce it to I-1. So you want to reduce I step by step, so that should be I minus minus. Okay, this is a for loop, guys. This is a for loop that I'm creating right over here, because you want to do that shifting again and again. You want to do that shifting again and again up till unless you want to start from n-1. You want to go up till including POS itself. So you will be decreasing I step by step so that you are able to do it. Okay, that is the for loop. Okay, and for each loop, what are you currently doing? For each loop, what are you currently doing? When I was n-1, okay, so this is I is equals to n-1, that is 2. What were you doing? So you were doing ARR 3 is equals to ARR 2. Am I right or wrong? What were you doing? ARR 3 is equals to ARR 2. That is, you were shifting 20 from the index 2 to index 3, guys. You were shifting the 20, that is the card 20, from the index 2 to index 3. How will you represent that mathematically? ARR 3 is equals to ARR 2. Are you guys able to understand this? Please do let me know. You are shifting the element 20 from index 2 to index 3. How will you represent it mathematically? Okay, ARR 3 is equals to ARR 2. Okay, that what does it mean? So ARR, so in terms of I, what does it mean? I plus 1, right now I is equals to 2, that is First of all, I is equals to 2. Okay, so ARR I plus 1 is equals to ARR I. Okay, in the next step, you are going to reduce I. So I minus minus. Now I would be equal to 1. Okay, in the next step, I is equals to 1. When I is 1, what are you going to do? ARR 2. Okay, ARR 2 is equals to ARR 1. Okay, you want to shift the 10 from here to here. That is ARR 2 is equals to ARR 1. When I minus minus, so you are decreasing. First of all, I was equal to 2. Then you are decreasing it to 1. Then again, you are doing the exact same thing. That is ARR I plus 1 is equals to ARR when I is equals to 1. Okay, so that is the exact same thing that we want to do inside of the for loop as well. Okay, that is the exact same thing that we want to do in the for loop. So inside the for loop, what are you going to do? Inside the for loop, what are you going to do? You are going to do ARR I plus 1 is equals to ARR I right over here. So this is the for loop that you would have to create. Are you guys able to understand this? Please do let me know. Are you guys able to understand this? Please do let me know, guys. See, just apply your brain. This is just common sense. Okay, this is nothing related to programming. Okay, like whatever you were doing by hand with your cards. Okay, when you had the cards in front of you, were shifting it one place at a time. You're doing the exact same thing right now using code. That's it. There's no difference in it. You're doing the exact same thing using code. Just apply logic, apply common sense. It is done. It's all about logic and common sense, and then just like understanding how to write code. Are you guys able to understand this? Please do let me know, guys. Means sir, we have to do it manually. I thought that if we insert any element at an existing index number, then it will replace the previous number. That is called as replacing an element, not inserting an element. See, there's a two difference between the word insert and replace. This is English, not programming. Okay, insert means you want to insert something. Okay, so for example, there's a human being standing in front of you. Okay, you're taking a knife, you are plunging it into that human being. Okay, it is not that his liver will be just replaced by, or his stomach will be just replaced by your knife. Okay, now the stomach is in your hand and the knife is in the stomach itself. It's not going to happen like that. Okay, that is replacing something. Okay, insert, when you are inserting something, when you are inserting your knife into that stomach, the stomach basically opens up, creates space for that knife to exist in his abdomen. Okay, so that is what I'm trying to make you guys understand. No, I will not be using Hindi. Okay, so that is what I'm trying to make you understand. There's a difference between insert and replace. Okay, right now we are inserting an element in this particular problem statement. Okay, are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. So let's go back and write the code for this. You have to do it manually, as you are able to see right now. Okay, we are doing it manually. We are removing the elements further manually. Okay, so we'll write our code for insert right now. So first, for int I is equals to n minus 1, I is less than equal to POS, I minus minus right over here. And then you are going to have your ARRI plus 1 is equals to ARRI. Okay, right over here. Now you are using arrays as well. Okay, you are using arrays as well. So for that, you have to declare that you're going to require an array. So int ARR. Right over here inside the parameters, you are going to declare that, okay, I need an integer array as well that I need to use. You need to provide that inside the calling of the function as well. So ARR as well, you need to provide it to your insert function call. Okay, so now that you have moved the elements one place further, okay, now that you have is greater than equal to, I'm so sorry, is greater than equal to POS. Okay, so now that you have moved the elements one place further, you have created a gap at the index 1. Okay, you have created a gap at the index 1. So now that you have done with your for loop, there's a gap right over here. So now you just want to insert the X. Okay, you want whatever your X was. Okay, whatever your X was, you want to insert it right over here. So I want to insert 6 right over here. So it's very simple. Okay, you would be going back. Okay, you will be going back right over here and you will be inserting the element. So ARR, and then at the position at which you want to insert it, you want to insert X as well. Okay, so ARR position, at the position, once you have moved everything one in front, once you have just moved all the cards in front of you, then you want to pick the new card up that you want to insert, and then you want to insert it at the position that you want. Okay, so for that you need to provide it with the position as well. So in position that you want right over here, and then you want to specify it down below as well that you require the position. So let's specify it down below. Once you're done with it, what do you want to return? Okay, what is the new size of the new like once you have inserted a new element into your array, what is the new size of the array? Can somebody let me know? What is the new size of the array? Once you've inserted the element into the array, what is the new size of the array, guys? Can somebody let me know? What is the new size of the array, guys? That's absolutely clever. That is n plus 1. Okay, so the new size of the array would be n plus 1 after the insertion, because you have inserted something. Okay, you have inserted something, so the size is increasing by 1. So the return would be n plus 1 at the end. Now you're going to use all these information to basically print out the new array as well. So for that, I don't want to like write it again, so I'll just be copying it from right over here, Control C and Control V. Okay, so after insert, I need to have another. Okay, so after insert, and then you are having your new array that is getting printed. So I've written everything. I will just click on the run code. Let's see what happens. So we are having error, X was not declared in this scope. Did we not provide it with X? No, we did not provide it with X. So we need to provide it with X as well. So let us provide it with X. So int X as well we need to provide it with, and we need to provide it down below as well in the function call. So X as well we need to provide it with. Now we'll be clicking on run right over here, and as you're able to see, we are having 5, 10 and 20 before insert, and after insert we are having 5, 6, 10 and 20 as the answer. Are you guys able to understand this? Please do let me know. Are you guys able to understand this? Please do let me know, guys. Please, after the end of this class, try to code this again. Okay, after the end of the class, please try to code it again. Just don't listen to me right over here and then like you just forget about everything. Coding is all about practice. The more that you practice, the more you will be able to retain and understand. Okay, so after the end of this class, please go back and code it, guys. Okay, it's very important. Okay, it's very important, guys, that you are able to go back and code it once again, guys. Please do not forget about it. Okay. Okay, so let's put it up right over here as well. We are going to include hash include vector. For those who are late in the class or are asking to explain the logic again, just I've explained it almost 2 to 3 times. Watch the video again, you will be able to understand it. Okay. Okay, great. So right now what we are going to do is we are going to use the exact same thing using vector. Okay. Okay, so okay, so right over here we are now doing the exact same thing using vector. Okay, the exact same thing that we are going to do using vector itself. That is our aim. Let's first create a vector. Okay, so to create a vector, the code is extremely simple. Vector int, and then we are going to create our vector that we want to have. Let's first name it something. So we are going to name it as ARR itself so that we are able to remember it, and then we are going to create our vector. So that was 5 comma 10 comma 20 right over here. So I think so that was the example that we were using right over there. Okay, the answer that we were like the same example that we were using right over there. So this is how you are able to create a vector. So this is a vector of integers. Okay, this is a vector of integers called as ARR. Okay, this is a vector of integers called as ARR. Okay, now when you are using a vector, okay, when you are using a vector instead of using indexes, okay, when you are using a vector and you are using index, so when you are using arrays, you are using indexes right over there. Inside of vectors, you usually use pointers. Okay, you usually use pointers. You don't use index indexes. So let me just explain that right over here. For example, this is our array. Okay, let's create an array and a vector. It looks the same while drawing it, so I'll be creating it using two different colors itself. So the array, I'm creating it using red. Okay, this is a fixed size array of size 5, and we are having 5, 10, 20 right over here, dash dash, and we are creating a vector as well. So vector does not need to have a fixed size, so it is going to have a size of 3 itself. That is 5, 10, and 20 right over here. Now when you were doing the insert and everything for an array, okay, when you were doing everything for an array, you were using 0, 1, 2, 3, 4 as your indexes. Okay, inside of your vectors itself, inside of your vectors, you don't use indexes, you use pointers. So this pointer is accessed by what is it? So for example, the name of this particular vector is ARR. Okay, so it is ARR.begin, begin. Okay, this is the first particular like pointer to the first element. Okay, so instead of using 0, you use ARR.begin. Okay, you use ARR.begin. You want to go to the next element, you will write ARR.begin. Okay, +1. Okay, you are going to use ARR.begin +1 to access the second element, and to access the third element you will be using ARR.begin. Okay, and then +2 right over here to access the third element, and so on and so forth. So instead of using indexes right over here, you use pointers in vectors. Okay, you use pointers in vectors. Are you guys able to understand this? Please do let me know. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. So we'll be seeing how to use them as well. But first of all, to understand that instead of using indexes, so when we are using n, okay, or I right over there, so for the iterator that we used to iterate over the indexes, we were using I, and I was equal to, let's say, 2 or something like that. So we were using integer. Okay, int I is equals to 2. We were using int I is equals to 2. That was the iterator that we were creating, because we were iterating over your indexes itself. Okay, we were iterating. So inside of your normal arrays, we were creating int I is equals to 2, because we were iterating over the indexes itself, and indexes are numbers, so we were using 0, 1, 2, 3, 4, 5. Okay, but when you are creating a pointer, okay, when we are creating a pointer inside of array, okay, if you want to create an iterator to iterate over the pointers itself, you will be creating it as auto. Okay, auto it is equals to, just like taking up a random thing, is equals to vector. What is the name of the vector? Let's say array. Okay, so it is equals to ARR.begin +2. Okay, that is the second element that we are having at the index 2. Okay, so this is how you are able to create an pointer itself, guys. Auto it is equals to ARR.begin, and then like you are having the parenthesis as well, +2. Okay, are you guys able to understand how? So for example, the iterator that we used previously was I, but this time the iterator that we are going to use is it. Okay, this is the iterator that we want to use, it. Okay, are you guys able to understand this? Please do let me know. So for example, if you want to insert, okay, if you want to insert an element at, so for example, let's say that I want to insert 6. Okay, x is equals to 6. At position is equals to 1. Okay, this is the problem statement that I'm having. I want to insert 6 at the position 1. So first of all, I will create an iterator at which position I want to insert it. Okay, at which position I want to insert it? I want to insert it at position 1. Okay, so I will first create the pointer to that particular position. Okay, I want to create a pointer to that particular position. Just like I was an integer, so you were using int. Similar to that, it is a pointer, so we are using auto. Okay, we are using auto. It's a keyword. So auto it is equals to, we need to create a pointer that points the position 1. We want to create a pointer that points the position 1. So that will be auto it is equals to ARR.begin parenthesis +1. This is how we are able to create a pointer. Okay, so let me just remove everything from right over here so that you guys are able to see everything clearly. So here we are able to create a pointer that, so this pointer basically points out to this particular element. Okay, this particular element itself. Okay, are you guys able to understand this? Auto is basically just like you are having int for I. Similar to that is a pointer. So for pointer we are having auto. Okay, just for integers we were having int. It's a pointer. So for pointer we are having auto right over there. It's a keyword. Okay, so right over here, as you're able to see, this will create a pointer that points to this particular element. Okay, now to insert an element into the vector, okay, to insert an element into the vector itself, okay, are you guys able to understand this? Please let me know. Yes, arr.begin is something that you have to use. Okay, auto is for your pointers itself. Okay, if you want to learn more about pointers, we have an entire video on our channel. You can go there, learn everything that you want to learn about pointers. Okay, that is the reason why I've told you guys again and again to go and visit and watch that video. Okay, so it will take some time, but you have to go and watch it correctly. Okay. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. Okay, so now to insert an element into a vector, it's very simple. Okay, you create an iterator right over here. So like basically this is the syntax. So you have to write this. There's no other option. That is auto. Let's just select a random name. Let's say iter. Okay, right over here is equals to arr dot insert. Okay, let me just clean it up because it looks very shabby. I need some space to write it down. So let this up right over here. Let us select this particular portion. Control X, Control V. Down here. Up. So we have to write auto. Okay, iter is equals to arr dot insert, and then inside of insert we have to specify the position that we want it to be inserted. That is our it. That's the iterator that we have created. So it, and what is the element that we want to insert? That is 6. Okay, that is inside of the arr vector. Okay, inside of the arr vector right over here, we want to insert 6 at the position it. Okay, we want to insert 6 at the pointer it. This is how you are able to create, you are able to insert an element into a vector instead of having like all those insert function that you have to create. This particular sentence directly does that for you. It does that for you. So let us look at that from like a programming perspective. Okay, so I've created our vector right over here. As you're able to see, a simple vector that we have created. We are then going to create auto it. Okay, that is vect arr dot begin plus 1. That is the position that we want it to be inserted in. Okay, then we want to create auto iter. Okay, this equals to arr dot insert. Yes, arr dot insert is an inbuilt function for vectors that are present. Okay, that basically handles everything for you. You don't have to do anything about it. It comma 6 is what we want to insert at the index 1. Okay, so that is what we have to do. Now to print it out, okay, to print our new array out, what you have to do is you have to create a for loop. Okay, for I int I is equals to 0, I is less than the size of the vector. So we don't know the size of the vector. Let's say that we don't know the size of the vector. For that as well, you have an inbuilt function that is there in vectors. Okay, like I said, do you remember the second advantage of vectors was the rich function library that it is associated with. You don't have to do everything from scratch. It has a rich function library that you can use to do various stuff. So we want to get the size of the vector. Okay, we want to get the size of the vector. So we can directly do arr dot size right over here, and that will give us the size of the vector, that is n. Okay, and then I plus plus. Okay, once we have done that, we can then just see out less than arr, and then I, and then less than space end, and see out. We don't want to print anything else, so just leave it at right over here. Let's run this. Let's see what happens. And as you're able to see, we have inserted an element just using like 3 lines of code. Just 3 lines of code, and you have inserted an element into the array. Okay, vector is one of the examples of a dynamic size array. For C++, it's vector. For Java, it's array list, and for Python, it's just list. Okay, so as you're able to see, using just 3 lines of code, using the rich inbuilt function library that is associated with vectors, you were able to do it in such an easy manner. That is the second advantage that I talked about vectors. Okay, why vectors or dynamic size arrays is used. For Java, it is array list. Okay, are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. Are you guys able to understand this? Please let me know, guys. This is the second advantage of using vectors, that is its rich inbuilt libraries that you can easily use to do most of the stuff. Okay, you don't have to write or understand the entire insert function, create it, and then use it. You can directly do it using vectors, and you don't even have to care about like, okay, we only have a capacity of like 5 or something like that. You can insert as many number of elements as you want. Okay. Okay, that's great. So now that we have done this, that would be it for today's class. I will show you guys the attendance link for today, guys. Before doing that, guys, I will definitely request you guys to like today's video, so that it's really helpful to. So please take up a minute or two to just like the video and subscribe to the channel. Okay, it will be very helpful for us as well as for you guys as well. Okay. Thank you so much, guys, but please do like the video and subscribe to this channel, guys, please. Thank you so much. Let me just make your attendance link for today, guys. Okay. Usually I select the topic whatever I want to teach just like 5 minutes before the boot camp itself, so because that's why I don't have any notes or anything like that. And I don't even have the time to basically sit and think about what I'm going to teach tomorrow. So I usually go with the flow, whatever I think that's important, so I just teach that on the day that's needed. Okay. Let me just create the QR code for today, guys. It will take a minute. Please do like the video and subscribe to the channel, guys. It really helps us a lot. This is the QR code for today, guys. Okay. You guys can pause the video, scan it, do whatever you want to do. It will be very easy. Okay. Okay. Thank you so much, guys, for today's class. We'll be meeting again tomorrow at the same timing, that is 6 o'clock, and we'll be continuing our learning from right over there. Okay. Okay, guys. Thank you so much. Thank you.